Hi guys, Mrs. Delisin here. Welcome to another lesson of Algebra 2. Today's lesson is multiplying and dividing rational numbers. I will be going over a lot of examples today. It's a combination of multiplying and dividing rationals, and then with a touch of factoring and a touch of sum and difference of cubes. So this is going to be a lot. So hopefully you guys are going to be patient enough to go through all the examples. Let's start with something really easy, right? With no factoring involved. No variables involved or not quadratic. Just a simple 14 over 9 times 15 over 28. Of course, you could always just say 14 times 15 over 9 times 28. But the goal of the lesson is to break numbers into pieces and cancel them. Okay, I'm going to do that instead of just multiplying the top and the bottom because we have a goal that we have to go through. Okay, so let's start. I'm going to start with 14. So I have to break down or factor 14, and that is, I'm just going to make a really long line here. So I'm going to combine all the numbers on the top. So I have 14 would be 2 times 7. And then 15 would be 3 times 5. Okay. For the 9, I have 3 times 3. For the 28, I have a 4 and a 7. So I can still break the 4. So that is 2 times 2 times 7. Okay, all we have to do now is cancel out the numbers that are the same in top and bottom. So let's start with 2. I have 1 2 on the top. I have 1 2 at the bottom. So that's gone. 1 7 on the top. 1 7 at the bottom. 1 3 on the top. 1 3 at the bottom. And it looks like that is it. Correct? So now we have 5 left on the top. And then I have a 3 and a 2 at the bottom. That is a 6. So our final answer there is 5 over 6. Okay, moving on. For the next part, this is no longer a multiplication but a division. We know in the past that when we divide fraction, we do a reciprocal of the second number, right? The second rational number. So let's flip that first before we move on. I'm going to have 12 over 35. It's no longer a division, but now a multiplication. And I'm going to flip that. Okay, again, I'm going to make a really long line in here. I'm going to break the 12. 12 is 4 and 3. The 4 can be broken down into 2 and 2, right? So that's 2 times 2 times 3. 77 is that 11 times 7. Okay, and then we have 35 is 5 and 7. Can't be broken down. 10 would be 5 and 2. Okay, so we have broken down into pieces already. What we're going to do now is to cancel. So I have red pen here. 2 on the top, 2 on the bottom. Cancel. 7 on the top, 7 on the bottom. I don't have any 2. I don't have any 3. I don't have any 11. Okay, so what I'm going to do is I'm going to combine the leftover on the top, which is 2 times 3 is 6. 6 times 11 is 66 over 5. Let me highlight that. And 5. 5 times 5 is 25. So final answer is 66 over 25. Okay, not that bad, right? Okay, moving on. We now go to, before we move on, I am going to discuss something in here that is really important as we move forward. In this lesson, we will see how the math of multiplying and dividing rational expression is similar to that of irrational numbers. First, an important property to remember is that the denominator of a rational number cannot be 0. Oh, Wrong pen. Cannot be 0. The same holds true for rational expressions. Thus, for something like x over x plus 2, see this denominator here, we have to note that x plus 2 cannot be 0. If you solve this equation, you get what we call a domain restriction. So the domain restriction, from the word restriction, right? We restrict a x value or a y value, whatever that variable is, we have a restriction for it because we need to make sure that the bottom cannot be 0. Because when we know in the past, and we should know this one, that when we do a number divide by a 0, we can't do that because we cannot divide by a 0. So like say for example 1 over 0, this cannot be, this is an error, right? This is undefined. And if we do have x over x plus 2, we need to make sure that this bottom cannot be a 0, right? So what will be the value of x that will make the whole entire bottom 0? And of course, we know that that's a negative 2, because if that x is a negative 2 plus 2, that would be equal to 0, and we cannot afford to do that. So today, we're going to make sure that all our bottoms, right, the denominators, have the restriction. So let's say over here, we have an 8x over 21y cubed times 7y squared over 16x cubed. So I have a y cube at the bottom, and I have an x cube at the bottom. I need to know that the y, domain restriction, what would be the value of y, right? I can use any kind of value of y except 0. Because if this y over here is 0, I would have to do 0 cubed is 0, and then I do 21 times 0. And that will make the whole bottom 0, and that will now be undefined. So my domain restriction tells me I can make, DR means domain restriction, I can plug in any kind of value except 0. Okay, and I would also need to do the same thing for the other one. That x in the 16x cubed, that cannot be 0. Because if that x is 0, the whole bottom will be 0, and therefore, that will be an undefined rational. Okay, so that's what my domain restriction is. Now let's solve. I have an 8, I'm going to make a really long line. My 8x would be 4 times 2. 4 is 2 times 2. So that's 2 times 2 times another 2 times x. And then 7 would be just 7 times y times y. For 21, I have 7 times 3 times y times y times y. For 16, I have 4 times 4, or 2 times 2 times 2 times 2 times 2. And then, I need longer. And then x times x times x. Miss, I think you're exaggerating. Can I just do, like, simplify it right away over there? Of course you can, right? You can. But our job in here is to make sure everything is simplified, because we have a goal that we are looking forward onto the next page. Okay, so just bear with me. Now we have 3 2's on the top, so I can cancel 3 2's at the bottom. I have 1x on the top, so I can cancel 1x on the bottom. I have 1 7, so cancel that 7. I have 2y, so I can cancel those 2y. Oh, it looks like we don't have anything left at the top. Okay, so on the bottom we have, that's a 3 and the x and 1 2 right here. So 3 times 2, that would be 6. X times x would be x squared. And don't forget, you have another y over here. So you have 6x squared y on the bottom. And then what about on the top? We don't have anything on the top. We can put 0, right? We can put 1 on it. Okay? Because we technically have 1 left in there. Okay, because you know how this is 1, 1, right? 1 divided by 1 is 1. So we have 1 on the top left. Okay, so we have that as our final answer. Moving on. B. Oh, it is a division right here. So we need to flip it. But before you flip it, you need to make sure that you are doing domain restriction after and before. So before and after you flip, so all the denominators, all the possible denominators. Right now, our original denominators is this 3a, this a and b, and then a and b also. So for the 3a squared b, my a cannot be 0. Oh, wrong pen. My a cannot be 0 because if a is 0, that would make the whole entire bottom 0, and that will now be undefined. So we can't afford to have our a 0. We cannot afford for our b to be 0 also in here. And that's the same for the other one, for the a squared b squared. Both of those cannot be 0. So I don't have to say again that the a cannot be 0, b cannot be 0, because I already said that. Okay, now let's flip. I have 10xy squared over 3a squared b times 5, oops, wrong, times 6a squared b squared over 5xy. And now we proceed to multiplication. And please take note, over here, you know how this was at the bottom originally, but now we have this at the bottom. So we also have to consider that that x cannot be 0 and that y cannot be 0. So that is both top and bottom for original or before and after you flip the second rational. Okay? So, I know it's so confusing, yeah? There's too many rules. Let's break 10. That is 5, 2, x, y, y. 3 and 2. And a, b, b. For 3, a, b. 5, x, and y. So I have 1, 5 on the top, 1, 5 at the bottom. There's no 2. I have 1x top, 1x bottom, 1y top, 1y bottom, 1, 3 top, 1, 3 bottom. I don't have a 2. 2 a's cancel. I have 1b on the top. Okay. Oh, it looks like we don't have anything left at the bottom. But we do have a 2, a y, a 2, and a b. Correct? So 2 times 2 times b times y. So we have a 4by over 1. But technically, we can just say our answer is 4by. Okay, moving on. We are almost done. I know I'm going slow though, but you can always change the speed. We have simplify, state the domain. Right now, we are dealing with quadratic. We have an x squared plus 2x minus 8. So we cannot just say this is x times 2 times 2 times 2 times 2, right? We cannot just break the 8. We cannot just break the 2. We have to break this as if they are quadratic. So we are going to factor this. Okay, starting with x squared plus 2x minus 8. What number will give you, what factors of 8 that when you add them, you get a positive 2? So two numbers that when you multiply, you get negative 8. when you add, you get a positive 2. So that's a 4 and a 2. We have to make the 2 negative. So that's x plus 4. Oh, wrong color. Because red is for us to cancel. So we have an x plus 4, x minus 2. Okay? For the 3x plus 3 though, it's not a quadratic, but it looks like we can simplify that because they have something in common. So I can divide both of them by 3. So 3x divided by 3 is a x. And then 3 divided by 3 is a 1. So technically, I simplify this by doing this. Right? So if I distribute the 3 back, 3 times, plus 1. So 3 times x is 3x. 3 times 1 is 3. Okay, at the bottom, we have factors of 3 that will give us a 4. That's kind of easy, yeah? X plus 3 and x plus 1. Because 3 times 1 is a 3. 3 plus 1 is a 4. And then, of course, it doesn't look like we can do something with the x minus 2. We are going to leave x minus 2 as is. Okay. We are going, before we cancel, we need to make sure we do our domain restriction first. So for x plus 3, our x cannot, what would be the value of these x to make the whole thing equal to 0? So let's just do what we always do before. So x plus 3 equals 0, x is negative 3. So our x cannot be negative 3. Our x cannot be x plus 1 equal to 0. Right? We can even say not equal. So x cannot be equal to negative 1. And for the x minus 2 equals 0, x cannot equal to positive 2. So our x cannot be a negative 3. It cannot be a negative 1. It cannot be a positive 2. Because if it does, if this x is a positive 2, this whole entire thing will be 2 minus 2 equal, it will be a 0. And when that happens, it will become undefined. So we cannot afford for this x to be a 2. We cannot afford for that x to be a negative 1. We cannot afford for that x to be a negative 3. I hope that is clear. Okay, let's cancel. I have an x minus 2 on the top. I have an x minus 2 on the bottom. I have x plus 1 on the top. I have an x plus 1 on the bottom. So I have these left equals to 3x plus 4 over x plus 3. So this is your final answer. Okay? Moving on. Oh, okay. I don't like, you know, when the letter changed into an x to a k, it's kind of like, because we're so used to just factoring x. But the way you're factoring it shouldn't change. So let's start with, let us rewrite this k squared minus 1. Okay, so if I rewrite that, that's technically k squared plus 0x minus 1. Right? Okay, so I have, let us simplify them. The k minus 3 is a k minus 3. There is nothing we can do on that one. Times, parenthesis. You know how I don't have a b value in there? I have a value, I have k squared, and then I have a c, which is a negative 1. But I don't have a b value. I'm inputting 0x in it. I know, hopefully you remember difference of squares. So we are looking for factors of a negative 1. Right, two numbers that when we multiply, we will get negative 1. And when we add them, we will get a 0. Right? So technically, it's an opposite of each other. And that is not that hard because that is just a k minus 1 and a k plus 1. Okay, let's review that. If I multiply this two, pretty sure you will get a negative 1. if you add this two, pretty sure you'll get a 0. Okay, I am going to just write k plus 1 in it, because k plus 1 is k plus 1. But over here, that is a k and a k. A factor of 3. So two numbers that when you multiply, you'll get a 3. But when you add them, you'll get a negative 4. So that is just a x minus 3 and an k minus 3 and a k minus 1. Okay, let's see. Before we proceed, we need to make sure we did our domain restriction. This k cannot, for this to be a 0, this k will be, if that k is a negative 1, the whole thing would be a 0. So we cannot afford for our k to be a negative 1. We cannot afford for this k to be a positive 3. We cannot afford for this k to be a positive 1. Right? Or I can even write that in order 1 and 3. There you go. Okay. So let us cancel. Can we? That one is canceled with that. K plus 1 is canceled with another k plus 1. Oh, k minus 1 is canceled with a k minus 1. So there's nothing left. So when we divide two numbers that are the same top and bottom, we just have a 1. Right? Like say 3 divided by 3, it's a 1. 4 divided by 4, it's a 1. So that's the same idea here. Our answer is 1. Okay, all of that work, our answer is just 1, yeah? Okay, moving on. I think this is the last example, you guys. We have a plus 2. Remember our little friend division? So we have to flip this. I have a plus 2 on the top, a plus 3 on the bottom, times you have a squared minus 9, a squared plus a minus 12. I am going to, hold on, I'm just going to write that one first. And of course, a plus 2 is a plus 2. There is nothing you can do on that one. I'm going to rewrite a squared minus 9. So I'm going to rewrite that as plus 0x minus 9. Right? I'm looking for two numbers that when I multiply them, I'll get negative 9. When I add them, I'll get 0. So hopefully you are thinking of x plus 3 and x minus 3. Let's check. If I multiply 3 and a negative 3, I'll get a negative 9. If I add positive 3 and a negative 3, I'll get a 0. Okay, moving on. A plus 3 is a plus 3. Nothing you can do about that. I'm looking for two numbers that when I multiply, I will get negative 12. When I add, I'll get a positive 1. Two numbers that when I multiply, I get negative 12. When I add, I will get a positive 1. That's kind of easy, yeah? Positive a plus 4, a minus 3. Oh, look at me. I use x when I'm supposed to use a. Oops. A plus 3, a minus 3. There you go. Oops, sorry. Okay, before we cancel out stuff, we are going to look at all our bottoms before and after, right? We need to look at them because we need to do our domain restriction. Right now, our a plus 3, this a cannot be a negative 3. This a cannot be a negative 4. This a cannot be a positive 3. So a cannot be a negative 3, cannot be a negative 4, cannot be a positive 3. And remember earlier, this whole entire a squared minus 9 was at the bottom, right? So this was at the bottom before. So we also need to consider this. So a cannot be a positive 3, a cannot be a negative 3, we already have that. A cannot be a positive 3, we already have that. So we don't have to worry about it anymore. Okay, so I have an a plus 3 on the top, I have 1 at the bottom. I have an a minus t on the top. I have an a minus t at the bottom. So my final answer is a plus 2 left on the top, or you don't have to put the parentheses, or a plus 4 at the bottom. So you have a plus 2 on the top and a plus 4 at the bottom. Oops. Okay. So again, this is what we call a difference of squares, where the b value is missing, or it's not really missing, but it's a 0. Okay, again, we are hunted by the division symbol. So let us flip b minus 5, flip the second part. We have the b squared plus 2b goes on the top, and then the b cubed plus 8 go on the bottom. All over, very long. The b plus 2 is b plus 2. Nothing you can do about it. I'm looking for two numbers that when I multiply, I'll get negative 35. When I add, I'll get a positive 2. When I multiply, I'll get negative 35. When I add, I'll get a positive 2. So that is x. Here you go again with the x. B. Okay, b plus 7 and b minus 5. Right, let's check that. If I multiply 7 and a negative 5, I do get a negative 35. So that's correct. If I add positive 7 and negative 5, I will get a positive 2. So that is a correct combination. Moving on, we have a b minus 5 at the bottom. I'll put in a parenthesis because I would have to put my answers in. Uh-oh. Do you guys remember b cubed plus 8? This is sum and difference of cube. Specifically, this is the sum of cubes. And I am not going to go in detail on this, but you can, if you don't remember, you can watch the video sum and difference of cube. And this formula will just be a plus, maybe let's change the color. Our formula that we will be using would be a plus b. That it's going to be long, so there. A cubed plus b cubed equals a plus b, a squared minus ab plus b squared. And again, this lesson or this video is sum and difference of cube. Okay, so for my b, I will have b cubed plus 8 would be 2 cubed, right? Because, there you go. Because 2 times 2 times 2 is 8. And then b times b times b is b cubed. So my a value is going to be a b. That's kind of weird, yeah? Your a value is b. And then your b value is 2. So all I have to do is plug them in over here. That is equal to b plus 2. A squared, so b squared, minus a and b, that is b times 2, so I can just put 2b plus b squared, which is 2 squared. Then that is b plus 2, b squared minus 2b plus 4. So let's put that in here. This is b plus 2, b squared minus 2b plus 4. All right, there you go. So, cancel out. But before we do our domain restriction, this b cannot be a 5. This b cannot be a negative 2. Okay? And remember, you know how this was at the bottom before we flipped it? So this was at the bottom before we flip. And because this was at the bottom, we have to consider domain restriction on here also. So for the b plus 7, that b cannot be a negative 7. For the b minus 5, this b cannot be a positive 5, but I already have that in there. So I just do b cannot be a negative 2, cannot be a 5. Or maybe let's write that in order. Cannot be a negative 7, cannot be a negative 2, cannot be a 5. Okay, let us cancel out. I have a b plus 2 on the top, a b plus 2 on the bottom. B minus 5 on the top, B minus 5 on the bottom. So our final answer would be that on the top and this one on the bottom. So this is B plus 7 on the top and B squared minus 2B plus 4 the bottom. Okay? There you guys. There you go. So I hope that I hope that you remember some of the stuff that we did from the second quarter and the third quarter combined. Because this, again, the x squared minus 9 over here, we got that one from difference of squares lesson. And this a cube, b cube, we got that from a sum and difference of cubes. Okay? And the videos for those are available in Jupiter Ed. It's available in YouTube. And you can always rewatch them as many as you can. Okay, thank you everyone. If you have any questions, please let me know. I will see you guys on the next video.